Nice AP Chem peeps. Here we are. We're going to solve this thing out. And it says determine the OH minus and pH of 0.100 molar NH3 solution. Kb is equal to 1.76 times 10 to the negative fifth for NH3. This is one compound you need to recognize as commonly as a weak base. It can be a weak acid. Many times it will be in context. But here, you can kind of tell the context already because they give you a Kb value and they're asking for OH minus concentration. Awesome. And so how do we deal with this? Because this is a weak acid, we're going to keep going with our scheme. Weak base. And we're going to keep going with our scheme of always starting with a balanced net ionic equation. I'll show you how to set that up. Because we're not dealing with a weak base that's being mixed with a strong acid, we are not going to do stoichiometry, but we have something that's weak. It's going to involve an ice table. And then we can determine the pH and the H plus and OH minus. So we'll come up with how we're doing all that. So NH3, weak base. So if it's a weak base, that means that it actually absorbs a proton when mixed with water. So we're going to put this stuff in. NH3, aqueous, plus H2O. Because it's weak, it has the forward and reverse reaction. But if it absorbs an H plus, it becomes NH4 plus, aqueous. The ammonium ion plus, we're left, because water lost an H, we have OH minus. And this is what makes it the weak base, is it produces this OH minus ion. That's cool. But here's our net ionic equation, and that's what we start with. Then, no stoichiometry, but here we need to do an ice table because in order to figure out OH minus concentration, we know this concentration to begin with, it's going to be in equilibrium eventually. So we'll kind of set up our ice table. Here we go. And we're not going to worry about water because that doesn't show up in equilibrium expressions or equations. Yeah. So we start off with 0.100 molar NH3. And we're going to assume that there's no NH4 or OH minus to begin with. Remember that this concentration of H plus and OH minus to begin with is something that we just kind of assume that it's 0, even though in reality it is 1 times 10 to the negative 7th. It's much smaller than what this is. So we just kind of scratch that out for a moment. And then our change, because we're going to end up making products, we have to minus x, and it's only 1x because the coefficient is 1, plus x, plus x. And at equilibrium, we will have a concentration of 0.100 minus x, and x, and x. And so now that I have that, I can use my equilibrium expression and equilibrium value in order to figure this out. Something I want to check though, this says Kb. If it says Kb, I need to check my net ionic equation, and it should have OH minus as a product. It does, so this is a Kb equation. I can use it, okay? So, and my expression is basically concentration of NH4 plus times the concentration of OH minus over the concentration of NH3. So it's my products over my reactants, just like what we did before. But they tell me that the value for Kb is 1.76 times 10 to the negative fifth equals. And now I can put my concentrations at equilibrium into this expression. And I just have x times x over 0.100 minus x. Because I have this I want to go through and solve for x. Because I have this minus x, I can probably cross this out because, oh yeah, this exponent, it's less than times 10 to the negative fourth. I can assume that this is negligible. So I'm going to take out the minus x. And now when I solve for x, I multiply the 0.1 over to the other side, and I take the square root. So, because I'll end up with 1.76 times 10 to the negative 6 is equal to x squared, but then I need to take the square root, both sides. And I get x equals 1.33 times 10 to the negative third. And now, when I'm doing this and when I'm using my ice table, there's a couple things that I want to check. And this thing that I solved out for, and it's kind of getting, or it's really close to what I really want, and it asked me for this OH minus concentration and the pH. This is the OH minus concentration at equilibrium because that is X. And something you want to check, though, is what your units are that you started with in your ice table. Ice tables can have either moles or molar. In here, we had molar and or molarity. And so I wrote that up here at the top as a reminder to myself. I always go back and check this because if it was really moles that I used, which sometimes happens, and then I would have to figure out what the concentration is. And so use units in your at the beginning of your ice tables, so it kind of tells you what your X value actually is. So my X value, it's molar, and that's the concentration of my OH minus. That is one answer. And now for my second one, I need the pH, but this one's not as bad because I have OH minus concentration, and it's not H plus concentration. I need H plus in order to figure that out, or I know the relationship between pH and pOH. It adds up to 14. So from here, I can figure out my, pOH. It's equal to negative log of the concentration of OH minus, which equals negative log of 1.33 times 10 to the negative third. And when I do that, I get 2.877. So pH plus 2.877 is equal to 14. When I solve for the pH, I get 11.123. So now I have my pH. So a couple things, checking Sig Figs as well. I started off with 3 Sig Figs here and 3 Sig Figs here. I'm likely to have 3 Sig Figs for my answer, so I have 3 Sig Figs here. And yes, my pH does have 3 Sig Figs because for pH, it is weird. It is only the numbers after the decimal that count as Sig Figs. Yeah, it's logarithms. It's fun. And that's just kind of what it is. But besides that, we solved that one out. And on to number 4, you guys. See you in a bit.